Good morning, my name is Manuel Zarzo, and we're going to start today with the Unit 7, which is called Analysis of Variance. This first video is about an introduction about this technique, which is called ANOVA. Okay, and I'm going to introduce the problem or the need of this tool with the following example. Let's imagine that we have a computer factory that has to purchase batteries for a new model of laptop, and then we have to choose one out of the three possible suppliers that we are going to call S1, S2 and S3. Okay, so we have to decide which one is more convenient, and then the company makes the following experiment. So the company purchases 10 batteries from the three suppliers, and then this is the result. So they make an experiment which is to measure the time of operation until more or less the battery has a very low charge. Okay, and then these are the results from the first, second and third supplier, and these are the values. So in this case we will call that we have one factor with three variants. The factor is going to be supplier, and the three variants are S1, S2 and S3. Okay, so if we make a plot with the data, we have the following. So this is a scatter plot with the 10 values from the first supplier, the second and the third. And then we can compute the average. Okay, and then we can see that the first one has a lower average, but the second and the third suppliers have more or less the same average. But also we have to take into account the price. Okay, so let's imagine the price is 70 for the first, 80 and 85. Okay, well, so probably the first one is not the best because the time of operation is the lowest, and that is not good. So we want our batteries to last as much as possible. But we can see that the second and the third, the average value is so similar that we are not sure which one to choose. We can think that perhaps we can choose the third because the average is slightly higher, but the price is also higher than the second. So we're not sure if we should choose the second or the third. Actually, if we make a hypothesis test to compare the second with respect to the third, probably the result of the test will be that there are no significant differences at the population level. Okay, so this is what we are going to study in this tool. Well, the null hypothesis is that the three the three suppliers have the same average at the population level. Okay, so is there enough evidence to affirm that the batteries from the third supplier last longer than the rest, and then we should choose that? We're not sure, because maybe the second with respect to the third, the differences are not significant. Okay, so one way to resolve this would be to compare all possible pairs. But obviously, if instead of 3 we have 4 or 5, the number of possible pairs is too much. Okay, so this is not the approach. So the comparison of all possible pairs is not recommended, and then we have this tool that allows to make this kind of study. It is called Analysis of Variance, which is also abbreviated as ANOVA. ANOVA is an acronym of Analysis of Variance. It was developed in the years 1930s by Fisher, and this is a powerful tool to study the effect of one or more factors on the average of one variable. Although it is called Analysis of Variance, the main purpose is not to study so much the differences in variance, but to study differences in the mean, which is an important issue. Well, I'm going to explain the intuitive idea, the key formula. Okay, so by definition, the residual in statistics is defined as observed value minus predicted value. Okay, then we can rearrange this and put that an observed value is the predicted plus the residual. And then if we subtract the average of all data in the left side of the equal and on the right side, okay, so this is mathematically correct. But then we can demonstrate that also this is mathematically correct if we make the sum of squared. Okay, so these things, if they are squared and we sum them for all observations, it is also mathematically correct. And this is the basic equation of ANOVA. Okay, this is not a mathematical demonstration, but this is just an intuitive idea to understand where the formulas come from. Okay, and they come from the basic concept of residual. Okay, so X bar is the average of all data that we have measured in our experiment. So every term has a name. We're summing things which are squared, so we call them sum of squares. And then this is called total sum of squares. Okay, this is called sum of squares of the factor, and this is called sum of squares of the residual, or residual sum of squares, because actually what we are doing is summing the residual squares. Okay. Then another concept is that when we divide the sum of squares by degrees of freedom, it is called mean square, and usually it is abbreviated like that. Sum of squares divided by degrees of freedom, it is called mean squares. And also there is a decomposition of the degrees of freedom. So we will have total degrees of freedom corresponding to this first term equal degrees of freedom of the factor plus residual degrees of freedom. Good. So this is what I have just explained. Okay, and then the mean squares total, or total means squares, is sum of squares total divided by total degrees of freedom, which is the total number of values minus 1. Okay, and so if we think about the formula, this is actually the variance of all the data that we have. Okay, so this is the first formula. Well, sorry, another formula. The total degrees of freedom is total number of values minus 1. All of these formulas are in the list of mathematical formulas that are available in poly format for this subject. Okay, also for the residuals. Residual mean square is equal to the residual sum of squares divided by the residual degrees of freedom, and also for the factor. Okay, so another formula is that the degrees of freedom for the factor is number of variance minus 1. Remember that in this case we have just one factor, which is supplier, and we have three types of suppliers, which means 3 variance. 3 minus 1 would be 2. Okay, then remember that, as I was explaining here, the mean squares is approximately like a variance. And then remember that we had this formula from previous videos. When we are going to compare the variance of two normal populations, we have this formula. The variance of a sample divided by the variance of that population, and everything divided by the sample variance of another sample taken from another population divided by that variance of the population. Okay, so we have two populations. We take one sample from the first population, another sample from the second population, and we apply this formula. Okay, so these statistical parameters follows a Fisher's distribution, being the degrees of freedom n1 minus 1 in the numerator and n2 minus 1 in the denominator. Okay, so this formula is simplified in the case of both populations have the same variance. In this case, we have that the ratio of sample variances follows a Fisher's distribution. Well, in this case, okay, as I have just explained here above, the mean squares is approximately like a variance. Okay, so when we make the ratio of two mean squares, this is approximately the same as the ratio of two variances, and this will follow a Fisher's distribution. Okay, and this is the key issue of ANOVA that I will explain in further videos. So here we finish this first video about an introduction of ANOVA. Thank you very much for your attention.